Number 2, we're going to name the property of equality that justifies the statement. Our hypothesis is 3x equals 42, then x equals 14. So what step would we have to take to get 3x equals 42 to equal x equals 14? Well, if you were asked to solve this equation for x, you would have divided both sides by 3. And you would have been left with x equals 42 divided by 3, which is 14. So that's the division property of equality. Number 4, we have m plus n equals 20, and then we're told that m also equals 10. So what they do in the very last step is they've said that instead of m plus n equal 20, it's 10 plus n equals 20. So they've replaced this m here with what they said it equaled, 10. When you replace one value with another, that's the substitution property of equality. Number 6, you have exactly the same thing on both sides of an equation. AC equals AC, and that's simply our reflexive property of equality. Number 8, we have x plus y equals y plus 3, then x equals 3. Now this one almost looks like the transitive property, but it's only if it was, if for transitive property, it would have to say x plus y and, or x equals y and y equals 3, then x equals 3. So you have it separated by the word and then. And here you have an equation. There's no and. So what they've done here is they've subtracted y from both sides of the equation, and that left them with x equals 3. So they use the subtraction property of equality. Okay, number 10, this is our given, our equation. And even if you don't know really how to deal with quadratics, that's when you have a square or a cubic or anything like that, it's okay because we're really just looking for how did the first step become the second step. Well, step 1 is always our given because it's basically asking us why is negative 2x times x plus 4 equal to so forth. Well, the reason that this is what it is because it was given to us. Okay, on the next step, the negative 2x becomes a negative 2x squared. Well, what happened here is they did negative 2x times x, and x times x becomes x squared. Then we did negative 2x times 4, which is negative 8x. And nothing has changed on this side of the equation. So the property that we've used is the distributive property. Okay, so next, how does this step become step 3? Well, the negative 2x squared is missing here. Negative 8x has stayed the same. X here has stayed the same. The positive 27 has stayed the same. And once again, a negative 2x squared has disappeared. Well, you can't just get rid of a negative 2x squared. The only way to get rid of a negative 2x squared would be if we added 2x squared to both sides of this equation. If we add 2x squared to both sides of the equation, they eliminate each other. So that's the addition property. Okay, so how does a negative 8x equals x plus 27 become negative 9x equals 27? So negative 8x got smaller. It became negative 9x. And x became 0 because we don't see it anymore. So how does a negative become even smaller? Well, you would subtract from it. A number gets smaller by subtracting from it, unless it's division, in which case more than one number would have to get equally smaller. So we've subtracted a positive x from both sides, or just subtracted x from both sides of our equation. That's our subtraction property of equality. And then our last step is how does a negative 9x equals 27? How does that become x equals negative 3? Well, we would have had to divide both sides by negative 9. That would have eliminated the negative 9 here, and 27 divided by negative 9 is negative 3. So we divided both sides of our equation by the same number, and that's the division property. Okay, number 12. The equation that we've been given is x minus 1 equals 1 over 23 times x. This is our given equation. looking at step 1 to step 2, x stayed the same, negative 1 disappeared. 1/23 x stayed the same, positive 1 disappeared. So how do you get two numbers to disappear? Well, you would have to either add or subtract. So there was no number here. It got bigger by 1. So this, if you can imagine, this says plus 0 became a positive 1. So we would have had to add 1 to both sides to make a 0 become a positive 1. So that's the addition property. Okay. Step 2 to step 3. X got 23 times bigger. 1/23 is gone from this x, and then 1 got 23 times bigger. The key word I'm using here is times bigger. The only way to eliminate a fraction is to undo the operation that a fraction represents. A fraction represents division, and the only way to undo division is to multiply. Remember, opposite operations undoes the operation. So we multiplied everything in our equation by 23. That's how x became 23x. That's how 1/23 became x. And that's how 23 became 23. We used our multiplication property to make everything bigger by 23. Step 3 to step 4. 23x became 22x. So it became smaller by 1x. X disappeared, became a 0, so it became smaller by 1x, and 23 stayed the same. So becoming smaller by 1x means we subtracted 1x from both sides of our equation, and we got 22x equals 23. And finally, step 4 to step 5, how do we isolate our x so that it's all by itself? And how did 23 become 23 divided by 22? Well, 23 divided by 22 is clearly the division property. We've divided both sides by 22.